Alright, let's take a look at a reciprocal quadratic function. So here we have a reciprocal quadratic function, so you can see that the denominator here has a degree of 2, right? And let's assess some of these characteristics that include domain range, asymptotes, intercepts, and we'll also take a look at the end behavior. Okay, so let's start with the domain of this function. So when you're looking at the domain, once again, you're just kind of assessing the denominator. You're trying to look for restrictions. So the denominator here, you notice that x belongs to our real number, but what really makes the denominator 0 and what makes it a restriction is that x cannot equal 3, right? So you can actually notice that here, right, x minus 3 cannot equal 0, so therefore x cannot equal 3 if you move the 3 to the other side, right? So x cannot equal 3, so this is the restriction on the denominator. Let's take a look at the range. And you can notice that this is really the same methodology as when we looked at the linear reciprocal functions. So when you're looking at the range, you can notice that this value here can never equal 0, because the only way to make a fraction 0 is if the numerator is 0. And as a result, you can notice that y belongs to all real numbers, and y cannot equal 0 minus 2 doesn't happen, so y cannot equal negative 2. Okay, so that's also very important to understand, right? Okay, so beyond that, what we need to do now is we need to also assess the asymptote. So we know that the restriction on the domain represents a vertical asymptote, right? So the vertical asymptote is basically x is equal to 3. So this is a value on the graph that the graph won't cross, right? It's a vertical line because it's associated with x, and this is a boundary that x cannot be. And then we know that the horizontal asymptote in this function here, right, is y is equal to negative 2. Okay, so this is the horizontal aspect that the graph won't cross. Okay, so now that we have both of these cases, right, the next thing you want to look at here is the intercepts. And beyond that, after we find the intercepts, we can create a much more refined sketch. So let's take a look at some of the intercepts here. Let's start with the x-intercept. Okay, so let's find the x-intercept. I'm going to let f of x, or y, equals 0. So if I let y equal 0 here, you get 2 over x minus 3 squared minus 2 is equal to 0. I'm going to move the 2 to the other side. You get 2 over x minus 3 squared is equal to plus 2 over 1. What I'm going to do is I'm going to do the reciprocal, and you get x minus 3 squared over 2 is equal to 1/2, right? What I want to do here is I want to isolate for x. I'm going to multiply this by 2, and I'm going to do the same thing to the other side. And here you get x minus 3 squared is equal to 1. And if you want to solve for x, what I'm going to do is I'm going to do the square root. I'm going to do the same thing here, and then the square and the square root cancel out. And remember that the square root of 1 is basically plus minus 1. So this indicates that we're going to have two x-intercepts. So one of our x-intercepts here, x is equal to plus minus plus 3. So one of the x-intercepts is x plus 1 plus 3, which is 4. And the other x-intercept is negative 1 plus 3, which is 2. So you have 4 and 0 and 2 and 0. So those are our two x-intercepts. Now let's find our y-intercept so we can create a much more refined sketch. So the y-intercept here, I'm going to let x equal 0. If I let x equal 0, I'm doing f of 0 here is equal to 2 over 0 minus 3 squared minus 2, which is 2 over negative 3 squared minus 2, which is 2 over 9 minus 2. And you can write the negative 2 here as 2 over 9 minus 18 over 9, which is negative 16 over 9. Okay, so you get negative 16 over 9. This is approximately, it's a little less than negative 2, right? So you can think about this as negative 7 over 9 if you want. And what you can do now is let's create a sketch of this function. Okay, so I have all my information that I need. I'm just going to create a grid system out here. Okay, hopefully I have enough space to kind of work with this. Alright, so this is like negative 2, negative 4, alright, negative 6, this is 2, this is 4, this is 6. Alright, so I'm just going to go up by 2's here. Or you can create a much more appropriate scale. Okay, so what I'm going to do here is I'm just going to get rid of some of these values, right? So we kind of did the calculation already. So we have negative 16 over 9 here. Just going to redo that, rewrite it so we can. Okay, so we understand that, and what we want to do here, let's plot these points. So let's first plot our vertical asymptote. So our vertical asymptote, let's just do it in red, x is equal to 3, so it's going to be in the middle here. And what happened there? Okay, so this is my vertical asymptote, x is equal to 3. My horizontal asymptote, and I would advise you guys to use a ruler for this. My horizontal asymptote, let's do it in green. It's going to be y is equal to -2, so let's say it's here, right? So horizontal asymptote, y is equal to -2, and let's plot our intercept. So one of our intercepts here is 4 and 0, so let's say it's somewhere here. This is 4 and 0. The other intercept is 2 and 0, so let's say it's here, right? And we also have an intercept at -16 and 9, so let's say it's like somewhere here. Okay, so this is 0 and -16 and 9, and now we can create our sketch. So if we're creating our sketch here, let's do that in yellow. Okay, so you can notice here that one of our graphs will look like this, and the other graph is in the adjacent quadrant will look like that. Okay, so you can see that the end behaviors that are close to the asymptote, what I'm going to do is I'm going to try to fix this up a little bit. Close to the asymptote are both going to positive infinity. And this is actually a hallmark feature of reciprocal quadratic functions, right? So let's take a look at our end behaviors. So if we're looking at our end behaviors, this is using a different color, right? And using this graph, we're looking at our end behaviors. Right, so if we're looking at end behaviors, first I'm going to assess x is approaching negative infinity. So I'm going to the far left of my Cartesian plane. So you can notice here that y here is approaching the horizontal asymptote, and it's approaching it from up top. As x approaches the vertical asymptote, let's say the vertical asymptote here is 3, right? This is 3 from the left side, this is 3 from the right side. If we approach the vertical asymptote from the left side, y approaches, and you can see that if you follow the trace, y gets closer and closer and extends all the way to positive infinity. As x approaches 3 from the right side, you can notice that y is also approaching positive infinity as well. So as we go this way, y will get higher and higher all the way to positive infinity. And furthermore, as x approaches positive infinity, right, you can see that as we go this way, y actually gets closer and closer to the horizontal asymptote, and it's from the top half as well. So you can notice that as x approaches positive and negative infinity, the horizontal asymptote is being approached at the same direction, and as x approaches the vertical asymptote from both directions, you also approach the vertical asymptote from the same direction. So there's just a sense of symmetry associated with these quadratic reciprocal functions, right? So it's almost as if the vertical asymptote creates a line of symmetry, but this is the idea, right? So you have to understand that some of these functions, they'll have different characteristics. It's really important to kind of understand some of these characteristics, and probably the best way to do that is by sketching.